Scientists often use numbers that are very, very small or very, very large. An example of a very small number might be 0.00003. An example of a large number might be 30000. This small number, notice, is much smaller than 1. And this large number is much larger than 1. So if we're thinking about a number line where we start at 0 and we go all the way up to some other number, let's just imagine that we have our number line. Small numbers in general are between 0 and 1, and large numbers are anything larger. Clearly, we can write numbers that only have ones or 10 digits. So, for instance, 1, 2, 3, or 10, 20, 30, or even 100, 200, and 300 are pretty easy numbers to write and to comprehend. However, as we start getting larger and larger numbers with more and more zeros after the first digit or more and more zeros after the decimal place, then we might want to think about a different notation that we could use to represent those numbers so that we don't have to write down all of the zeros or all of the decimal places. To write very large or very small numbers, scientists use scientific notation. In scientific notation, we use a base number, so 0.0003 would have 3 as the base number, and then we use a times 10 raised to some power to indicate how where the decimal place is supposed to be. So for a small number, this decimal place will be negative. So from the 3, I have to move 1, 2, 3, 4 to get to the decimal place. So this would be a 3 times 10 to the minus 4. For very large numbers, such as our 30,000, we would have 3, and then the decimal place is clear to the right, and so we would have 1, 2, 3, 4 decimal places after the 3. That's a large number, and that exponent for the 10 will be positive. So scientific notation numbers that have negative exponents are small numbers, and scientific notations that have positive exponents are large numbers. If we think about our number line again, so let's imagine that here is 1, and clear over here someplace is, 10,000, some big thing over here. If I move the decimal place to the left, so if I make this number less than 1, I'm moving to the left, and towards the left goes towards negative numbers. And so my exponent on the 10 is going to be negative for these numbers here that are small, and is going to be positive because as I move to the right on the number line, I'm going more and more positive. So I have positive exponents when I have large numbers. So if you kind of think about the number line that way, that may help. So negative exponents mean very small numbers. Positive exponents mean very large numbers. The value of that exponent, so the value of that exponent is telling us about where the decimal place is relative to the first non-zero number. So here the first non-zero number is 3, so I have a 3. And then my decimal place is 4 to the right of the 3. So I have a positive 4 as an exponent. Here, My first non-zero number is 3, and then I have 1, 2, 3, 4, the decimal place is 4 to the left of the 3, so to the left is a negative 4. So what if we have a number like 34,829? What would we do to put that into scientific notation? Well, again, we're going to look for the first non-zero number. The first non-zero number is 3, and so it's going to be 3, and then the decimal place is going to go after that first non-zero number, so 3 point, and then I put the rest of the numbers, 3.4829, and then I ask myself, how far would I need to move the decimal places? How many places would I need to move the decimal in order to get back to the original number? So I have to move this decimal 4 places, and so that makes this a times 10 to the 4th. If I have a small number, let's say it's 0.0000004562. So again, what I'm going to do is I'm going to look for the first non-zero number, and I'm going to write 4 and then the decimal place, and then the rest of the non-zero numbers, or the rest of the numbers after that, 562. And then I'm going to ask myself, how far do I have to move this decimal place in order to get back to this original number? So I have to, if the decimal place is here, I have to move it 1, 2, 3, 4, 5, 6, 7. And so this is a very small number, so it's times 10 to the minus 7. Notice that I've moved my decimal place to the left to get back to the original number, and so that's negative 7. So that would be how I would change a number from regular decimal form to scientific notation. Decimal form to scientific notation. If I have a number in scientific notation, so let's say I have the number 4.056 times 10 to the 7th, and I want to change that into decimal, then I am going to just look at this exponent and ask myself, do I move the decimal to the right or to the left? So this is a positive number, so I'm going to move it in the positive direction. And so I would have to write 4, and then I'm going to go 1, 2, 3. So 4, 0, 5, 6. That's moving it 3. Now I'm going to need more zeros because I need to move it 7 places. So that's 3, 4, 5, 6, 7. So this scientific notation number in decimal would be this. I can check myself to see whether I did that right. If my decimal is here, so if I move it 1, 2, 3, 4, 5, 6, 7, I get to this base number. So that's how I would change a number from scientific notation into decimal form. Let's do that for a small number. So let's say I had the number 3.206 times 10 to the minus 5. So if I'm in scientific notation, this exponent on the 10 tells me which way to move the decimal. So it's negative, so I'm going to move it in the negative direction, and I'm going to move it 5 places. Okay, so we're going to want this to be 0.123, 1, 2, 3, 4, 5. So let's check that out and make sure I did that right. 1, 2, 3, 4, 5. That would put the decimal in the same place that it is over here. And so this number in scientific notation would be this in decimal form.